Engineering here at Toledo. It's my pleasure to welcome you all to the 8th in a series of seminars at the college that focuses on autonomous vehicles and smart mobility. I know that many of you attended our February 2018 kickoff seminar, which gave us an overview of the topic of autonomous vehicles. In April 2018, we discussed the importance of protecting communications between vehicles and infrastructure, ensuring the safety and cybersecurity of this data and information-rich smart vehicle ecosystem. In June 2018, we focused on public transportation and autonomous vehicles, and we were thrilled to host an actual autonomous bus. In September 2018, our seminar covered infrastructure, government regulations, and autonomous vehicles. We are very pleased to have the executive directors of both Drive Ohio and the Ohio Turnpike with us to discuss the state's efforts to coordinate and support autonomous vehicle testing. In November 2018, we addressed one of the most exciting subjects in this topic, accessibility and autonomous vehicles. We learned how smart transportation may be able to provide the elderly and the differently abled the means to remain active and engaged in the world. In April 2019, we heard from industry experts from Toyota and Ford on how the autonomous vehicle technology is changing automobile design and manufacturing. In December 2019, we were honored to host ODOT Director Dr. Jack Marchbanks and Rich Granger from Drive Ohio on the topic of workforce development and preparing your workforce for the future. Today, we're going to change tracks, so to speak, and look to the future of mass transit of both people and materials on something called the Hyperloop. The Great Lakes Hyperloop will allow passengers traveling between Pittsburgh, Cleveland, Toledo, and Chicago to do so in capsules moving at over 700 miles an hour. You'll hear about the exciting mobility and economic benefits of this technology shortly. Our next seminar will be in February 2021. Will include an opportunity for you to learn about how the world of autonomous transportation will affect the safety of pedestrians and bicycles. We join with our partners in this series, AAA of Northwest Ohio, in celebrating the achievements of fellow engineers and scientists in creating the technologies that I'm confident will significantly reduce traffic deaths around the globe and provide mobility to millions who would otherwise not have it. Thank you for joining us here today. And now it's my pleasure to introduce our MC for today, Ms. Lisa Guyton from the 13 ABC News. We've been very fortunate to have Ms. Lucy Guyton as our MC for this entire speaker series. Lisa has been a television anchor and reporter for nearly 30 years. She spent the last 15 years working at 13 ABC. Lisa grew up in Perrysburg and graduated from Maumee Valley Country Day School. She has a degree in communications from Stevens College in Missouri and is grateful to be doing what she loves in her hometown. She's been covering the auto beat for more than a decade. Of course, a lot of the recent coverage is focused on self-driving vehicles. Lisa also reports on many animal, business, and human interest stories for the station. She describes herself as fiercely loyal to our city, and Lisa's proud to be involved with events like Technology Takes a Wheel. In her free time, Lisa volunteers for a number of charitable organizations in the community. She also spends much of her spare time with Real Horsepower. Lisa is an avid equestrian who began riding horses at the age of 4. Please join me in welcoming Lisa.
Well, thank you so much, Dean Toole, and welcome and thank you to all of you for joining us today. It is my pleasure to once again serve as the moderator for this inspirational and informational event. The University of Toledo College of Engineering and AAA of Northwest Ohio are proud to host today's virtual event on the topic of the Great Lakes Hyperloop. Now, we have some excellent speakers on an exciting topic that will have an immeasurable impact on our city and on our region. As guests are joining us, I want to share a few housekeeping items about our virtual event. Attendee names are not visible to other attendees. They are only visible to hosts and presenters. Therefore, you will only see your name in the attendee list. For today's Q&A segments, we request that you submit questions using the chat box, which we will be monitoring throughout the session today. To access the chat feature, click on the chat icon at the bottom of your screen, and the chat panel will appear in the right bottom column. And please be sure to specify which panelist your question is addressed to. We always have wonderful questions from everyone. Additionally, if you'd like to change the view on your screen, you can click in the upper right corner of your screen to expand or reduce. I would like now to introduce our first featured speaker, Mr. Chuck Michael. Chuck Michael is an accomplished technology innovation thought leader with over 35 years of significant experience combining business and strategic planning, study, design, and construction of major railroad and mining projects and deep underground high energy physics labs in collaboration with the University of California, Berkeley, Fermi National Laboratory, and the National Science Foundation. He currently directs the U.S. feasibility studies for Hyperloop transportation technologies, applying skills in transport economics, transportation planning, heavy civil, structural engineering, and project management. His global project experience extends throughout the United States to Canada, Europe, Asia, and the Middle East. He completed his undergraduate studies in civil engineering with graduate studies in particle physics and structural engineering. He's a registered professional engineer and serves as a member of the MIT Technology Review Global Panel. Please join me in welcoming Mr. Chuck Michael.
Well, good morning. It is a pleasure to be here today. I'd also like to thank the University of Toledo for their ongoing series of technologies. And today we're going to talk about Hyperloop transportation technologies and the Great Lakes Hyperloop project that extends from Pittsburgh, Cleveland, Toledo, and to Chicago. Next slide, please. The topic of today's discussion is transport evolution and transport revolution. We have not seen a change or an additional mode of transportation in over 100 years. So this is going to be an exciting day for many of you, and we're so glad you were able to attend. Next slide. As we look at the modes of transportation that we currently have, we have the automobile, and we have the airplane, and ships and boats, and rail. And as I said, it's been over 100 years since we've seen a new mode of transportation. But today you're going to learn about that. Next slide. This is the Hyperloop. This is an extremely high speed, very efficient, extraordinarily safe, sustainable, frictionless, and profitable transportation system. We have designed what we believe to be the safest, most efficient mode of transportation ever devised. Next slide. This is a view of how it might work. This is an animation that shows an elevated section. And as we'll talk about today, we can build these as an elevated section or at grade or underground, depending on the specific needs. Next slide. This is a real capsule. This exists over in our R&D center in Toulouse, France. This was built in 2019, and it begins the definition of a new era of sustainable transportation, energy efficiency. We are carbon-free operations. We are incredibly safe by design from the ground up, extremely high-speed travel, fully connected. Every capsule and every system is fully connected with a control system, autonomous operation with no pilots, no onboard staff, and a frictionless ecosystem. As well, from an economic perspective, it is subsidy-free without any additional input of funds from local governments. Next slide. This is the heart of the system, and you'll notice that we begin with a tube. And the tube is around 4 meters in diameter, around 13 feet. For an elevated section, this would be a structural steel tube that would span between the pylons, probably around 100 feet. The tube has a series of pumps that reduces the air inside the tube. And we reduce that down to almost a vacuum, but not exactly a vacuum. We'll be at about 100 Pascal in terms of pressure. The room you're sitting in, no matter where you're at, is probably around 101,000 Pascal, which means we've taken out over 99% of the air. By taking the air out, we have removed all of the air resistance inside of the tube. Next, we insert a capsule into the tube, and the capsule is a pressure vessel. It is designed very similar to an aircraft fuselage. It has a magnetic levitation system that is, and we'll describe this a little bit more later, but it's a passive magnetic levitation system that will elevate this to a few, say 15 millimeters off of the guideway. The guideway is an aluminum track, and it is propelled after that with a linear motor. Next slide. So this is the capsule. It's about 100 feet long, about 8.7 feet in height, about the same size as the original jet inside. It has the passive magnetic levitation system. Passive meaning there is no energy input at all. We can elevate a 20-ton capsule off the track without any input of energy. And we propel the machine with a reimagined linear motor that we've designed. Top speed of this capsule is around 760 miles an hour, just under the speed of sound. Each capsule will carry around 28 to 50 passengers, depending on the configuration. We can also configure this for light freight with, say, freight containers rather than passenger seats. In a passenger configuration, we can carry around 160,000 passengers per day. Next slide. This is the passive magnetic levitation system. This was developed by Lawrence Livermore Labs, originally as a defense assignment, and we have an exclusive license for this for use in Hyperloop. You'll notice the permanent magnets are the boxes that are going up and down. They each have an arrow on them, and that's the north arrow for a magnet, as you know when you used to play with magnets when you were kids, or in my case, when you're an adult. So this passive magnetic levitation system creates a magnetic field once you move it along a reactive surface. In our case, we use an aluminum track. And as that moves, it creates the magnetic field, which gives us the levitation, again, with no energy input at all. Next slide. Again, this is an elevated system around 100 feet between pylons. We have the tubes mounted inside on top. And on top of the tubes, we have a cladding that holds a series of solar energy panels that allows us to generate our own energy as we go. And
Okay, I found this on the web for a series of solar energy panels generation. Check it out.
Sorry, that was Siri. The solar panels are sized to be able to generate more energy than we need on an annual basis, so we are energy independent. Next slide. Now, this is the variation in infrastructure that we're able to develop. On the left, you see an elevated system. This has the tubes with the pylons, with the cladding and the solar panels on top. The next one, second from the left, is an urban section. This allows for walkways and parkways on top of the tubes, as well as the solar panels. In urban areas, or where it's very congested, we're able to go underground. The third from the left is a shallow trench system, again with the tubes buried probably around 15 to 20 feet below the surface. And that allows the surface opportunities for farming or whatever the case may be, where we don't interrupt any of the existing operations on the surface. On the far right is a deeper tunnel system. We would use this in an urban setting such as downtown Chicago, downtown Cleveland, that allows us to take a straight shot into the station without interrupting anything on the surface in a very congested urban setting. So we have a real variety of construction techniques, all designed to minimize the impact on the environment. Next slide, please. This is a typical station. This particular one is a design concept for Abu Dhabi. It's a circular station. As you come in from the top, you go around the series of gates, if you will, similar to an airport, and you exit out the other side. In this particular station, we would have around 50 gates. They would be boarding and exiting each of the capsules in turn around the exterior of the station and then out the other side. This has a capacity of about 3,600 passengers per hour during peak times. An adaptive departure rate, we have a headway, is what we call it, of around 40 seconds. And we limit the acceleration in the Hyperloop to about 0.1 g, or 1/10 of gravity. This allows for a very comfortable initiation, acceleration, deceleration, because we're not sure if the passengers, they may range from a small baby to an elderly person, and this is a very comfortable rate of acceleration, so that even you wouldn't have to have a seatbelt on at this rate. Next slide. This is the route from Pittsburgh through Cleveland, Toledo, and Chicago. This particular route was the subject of a study that Kathy will be talking about, the Great Lakes Feasibility Study. We conducted this study over the course of about 2.5 years, finishing up the report in December of 2019 and publishing all of the information and all of the data in the report. It's a open book public document. Next slide, please. As I indicated, the Hyperloop system is able to operate on renewable energy, and that's the way it's designed. We have access to solar energy. If we have an underground system, we would either build a solar farm along the route, or we would cooperate with, say, a nonprofit or another entity that would build a solar farm, and we would purchase the energy from them. But in all cases, we would use renewable energy. It could be solar, it could be regenerative braking, which we build into the system. Anytime we slow down, we generate a lot of energy. We convert that kinetic energy into electrical energy. We have access to geothermal in some parts of the country, and we have access to wind energy in some parts of the country as well. Next slide. With regard to the environmental effect of a Hyperloop, we've designed this with a net zero carbon operations. And as you look at the life cycle of development of a Hyperloop, and that would be from design, construction, and operations, it's the most efficient use of energy of any transportation system. The graph on the right shows the comparison between Hyperloop systems and other internal combustion systems, high-speed rail, small aircraft, medium aircraft, large aircraft. All are large carbon generators. And again, from our design point, starting with a clean sheet of paper, we developed a system that has a minimal carbon footprint and net zero carbon emissions. Next slide. The new technologies that have become necessary to develop the Hyperloop, we've used many of the existing technologies, even the passive magnetic levitation system. But along the way, we've encountered situations where we needed to invent a new solution to an issue. The enclosed environment of the Hyperloop indicates that we are immune from weather conditions, as an example, from snow, ice, rain. We are separated from any other form of transportation. There's no at-grade crossings that you see with many other types of transportation. The shell, the skin of the Hyperloop required a new development of in technology with the carbon fiber system that we have embedded sensors throughout the carbon fiber and using multiple layers. This is called vibranium. We loaned it to Black Panther, and but in our case, it originated with Hyperloop, and this is the skin of the system. It's a sensorized carbon fiber composite. The sensors allow us to monitor continuously the structural health of the system. the speed, the location, all things that we need to know in terms of monitoring the successful operations of a Hyperloop system. It is quiet, it is clean, um, and it is unlike anything you've ever seen before in a transportation mode. Next slide. All transportation systems require monitoring, they require security, they require air quality concerns and how we address those. All of you have been through airports and you've experienced the joy of going through the transportation security systems. By designing this from the ground up, we're able to approach it in a different way. We have passive screening of all passengers. They wouldn't even know that they're being scanned in terms of looking for illicit materials. The biometric sensors operate as your identification. The air quality inside is enhanced with filters that will protect us from all the airborne particles, such as down to like a 2.5 microns. We have a rapid disinfecting system. We use ultraviolet as well as a proprietary application that we spray on all surfaces that will last for approximately 90 days to protect us from viruses and so forth. And the contactless travel, where we have no need to shake hands or do anything like that, but it's all a biometric screening and automated ticketing. Next slide, please. The stations at a Hyperloop, this on the top image is a typical station. This is a linear station. All of the Hyperloop capsules are nonstop from origin to destination. When you near a station on the main line, if you will, you take an exit off the main line and into a linear station, and you either enter or exit, and then the capsule leaves again. It's all on a demand system, so there's no scheduling. Again, we have about 28 to 50 passengers on each capsule, and so the routing is rather continuous. So when you go to a station, you don't necessarily need a reservation at all. You just walk up and you take the next capsule, and in a few minutes, you're on your way. Once you're inside, considering that we're moving at greater than 600 miles per hour, we don't have any windows, but we've created windows inside in association with other companies such as Reflect and some video game folks. And we have created an augmented reality, a window sitting next to your seat that is programmable. And you can choose whatever image or motion that you would like, if you want to see cows or if you want to see the Swiss Alps. But it gives you a sense of perspective in terms of if we showed you a picture going 700 miles per hour, it would simply be a blur and your brain really wouldn't process that all that effectively. So you can program in an image and it gives you a better sense of speed and space when you're inside the capsule. Next slide, please. When we designed the Hyperloop, it's a challenge funding and maintaining economically a high-speed transportation system. So what we have designed is, in the end, is a low cost, low construction cost, low operational cost, and low maintenance cost that is able to support itself from revenues in either passenger or freight categories. For the ticket pricing, we have a dynamic ticket pricing, which allows for discounts for, say, senior citizens or students or frequent travelers. We have on-demand mobility. Again, you just walk up to the station and take the next capsule going out to where you're heading. It has a very high throughput. around 160,000 passengers per day capacity. In an economic sense, considering that we work with the federal government on regulations and authority to construct, we evaluate the economics from their perspective, and it takes the form of a benefit cost ratio, so that if the benefits exceed the cost, you have a positive ratio, which makes you eligible for additional federal funding if that's required. We have a benefit cost ratio of about 2.15 that Dr. Metcalf will get into a little bit later, which is an extraordinarily high number. We have a very competitive return on investment, so that this is very attractive to the private equity markets and funding folks. And we have zero operating subsidies, which makes it very attractive to local, regional, and state governments. Next slide, please. In terms of projects we've completed, we have a research and development center that is completed. This is in Toulouse, France, in partnership with the government there. This is a 320-meter test system above grade, and has been in operation since, with optimization since early 2020 after construction in 2019. In the Emirates, we have a commercial prototype being developed in Abu Dhabi. This will be close to the expo site and close to the new Al Maktoum Airport. The concept design is complete, and we are awaiting start of construction later this year. We're also working on a cargo prototype in Hamburg, Germany, with a German partner, HHLA, and it is the largest port operator in that part of Europe. This would allow for the autonomous transportation of the seagoing containers, which is a very big market. And those of you that live near a port know that it can get extremely congested of containers at the seaport. Next slide, please. In terms of timeline, the upper left is a 320-meter full-scale system in Toulouse, France, that is complete. We are in the process of integrating all the systems right now. We have completed all the pressure testing as an example, and we're looking forward to passenger tests in the early to mid 2021, which would be the first passenger-ready system anywhere. In Abu Dhabi, we have the 3 to 5 kilometer commercial prototype. Once that is complete, it would continue south into Abu Dhabi City. And we also have a commercial line in terms of the development of capsules and systems for passenger safety and comfort. Next slide. In a regulatory sense, and in a commercial sense, it is necessary that these technologies be able to be insured. And we began working with the largest reinsurance company in the world, Munich Re. They have evaluated our design and construction approaches and have determined that we are indeed an insurable transportation technology. We worked with a European certification laboratory, TÜV to develop generic guidelines for Hyperloop. And these will be generic guidelines for the design, construction, and operation of Hyperloop, which up until this time didn't exist. We shared those guidelines with the European Commission, and last year we shared them with the US Department of Transportation. On the right there, you see under government guidance, the Department of Transportation eventually organized a council called the NET Council, NETT, that stands for Non-Traditional and Emerging Transportation Technologies. And this brings together all of the operating administrations within USDOT, such as the Federal Rail Administration, Federal Aviation, Federal Highway, Federal Transit, the pipeline folks, the vehicle safety folks, and we can sit in one room with this NET Council and their representatives, and we can discuss the Hyperloop certification for the U.S. In July of this year, the Net Council published this particular document, Pathways to the Future of Transportation, that specifically addresses Hyperloop and assigns Hyperloop to the Federal Railroad Administration in terms of the safety and operation of systems throughout the United States. So we're very happy that the US DOT is moving forward with their recognition of Hyperloop. Again, this indicates that Hyperloop as a maglev technology is eligible for federal funding for planning and for capital grants. And these grants would go usually to municipal governments or public agencies. Next slide, please. So in a snapshot, we have a full-scale system and passenger capsule that has been developed. We have the insurance and regulatory framework. We've acquired the proprietary passive magnetic levitation system, which is the heart of our system. We have over 10 global agreements with countries around the world. We currently have over 800 experts and 50 corporate partners as part of Hyperloop TT. We have over 45 patents, 60 trademarks, and a host of what you would call intellectual property and trade secrets that we have developed in order to develop the Hyperloop. We've organized a scalable organizational model in terms of how we organize projects, and we orchestrate the development of the projects. Hyperloop TT is not a contractor. We're not an operator. We would not be owning it, but we prepare the technologies and we license the technologies to qualified partners around the world. We have an asset-light licensing business model. This is directed towards the intellectual property that we provide as part of the operating agreements. And we also have a commercial readiness that is ready to launch, and hopefully if the Great Lakes Hyperloop project. Next slide, please. So now we have some time for questions. This is the artist rendering of the project going through Cleveland. So if anybody notices a tree that they recognize, that's somewhat intentional. So we can stand for questions if you have any right now.
First question, how many people can travel in a Hyperloop train at one time?
The capsule has a capacity of between 28 to 50 passengers, depending on the configuration that we have in each one.
How long is it going to take to construct a section of Hyperloop track?
We wouldn't build just a section. We would build a commercial project that would go from origin to destination. In the case of the Great Lakes Hyperloop project, if we begin in Pittsburgh and go through Cleveland into Toledo and Chicago, it would take about 6 years total to build that entire stretch. The reason we build a commercial segment is that when you develop your business plan and you ask for funding, that they're going to want to know how they get their money back. And the only way to get the money back is to have passengers and revenue from passengers and revenue from freight. So it would be a single commercial project taking about 6 years total.
Well, thank you so much for your time, Chuck. I really appreciate it. And of course, we're going to have a lot more discussion as we move on through the morning here.
Thank you very much.
Thank you. Up next, we have Kathleen Sarley. Kathy has more than 28 years experience in transportation planning and engineering. She is a registered professional engineer in the state of Ohio and is currently serving as Associate Director of Operations and Chief Operating Officer at the Northeast Ohio Area-Wide Coordinating Agency. Now, in this role, Kathy manages the activities of the agency's planning, programming, external relations and engagement, finance and operations, and administrative divisions. Now, she directs the collection and analysis of data, gives final review and approval of agency reports, documents, and study designs, and then monitors the budgets at all levels. She also helps the agency define, prepare, and communicate agency and project goals and objectives. Now, previously, Kathy was the director of planning at the agency. In that capacity, she oversaw the completion of transportation and environmental projects. She also looked at programs and studies and served as the project manager for the Great Lakes Hyperloop feasibility study, which evaluated the viability of an ultra-high-speed Hyperloop passenger and freight transportation system that initially would link Cleveland and Chicago and ultimately become a network on the East Coast. Now, before joining the agency, Kathy spent 21 years at the Ohio Department of Transportation, where she worked in many different capacities in design, as well as planning and engineering and administration for District 3, which is in Ashland, Ohio. Kathy holds a Bachelor of Science degree in Civil Engineering from Cleveland State University and a master's degree in Business Administration from Lake Erie College in Painesville, Ohio. Welcome, Kathy.
Thank you very much. Good morning, everyone, and thank you for inviting me here today. It has been a while since I've done a Hyperloop presentation. When we were in the thick of the feasibility study, I think I did probably 3 presentations a month. So I'm a little rusty, but I think I'm prepared. So anyways, this morning I'm going to take you through an overview of the Hyperloop study. Next slide, please. So a little bit about NOACA. In case you're not familiar, it's the MPO for the Cleveland area. We have about 2.1 million population, 5 counties, 166 cities, villages, and towns, and a 45-member board. We also are the host chair of Vibrant Neo 2040, which is 12 counties, 3.8 million population, 1,200 political jurisdictions, and a 30-member board. Next, please. So how we started the Great Lakes Hyperloop project is, or feasibility study rather, sorry. It got started with a public-private partnership between NOACA and Hyperloop TT. And they signed the agreement in February 2018. At the time, it was a $1.2 million study with 50% funding coming from NOACA and 50% from Hyperloop TT. And initially, the route was only between Cleveland and Chicago, and later on, we added Pittsburgh and also another $100,000 to the study. Next, please. So why Cleveland and Chicago? Why Great Lakes? Next. So as you can see on the map here, there's 2 major east-west interstates in the United States, I-90, which goes between Boston and Seattle, and I-80, which goes between New York and San Francisco. And if you look close, you can see in between Cleveland and Chicago, they converge into one route. So that made a lot of sense for putting a Hyperloop or proposing a Hyperloop corridor between Cleveland and Chicago. All the freight that goes through there, they all have to be on one road. All just people traveling. So it just made a lot of sense, and that was just one of the reasons. Next slide. There's also a connection between Cleveland and Chicago by all the goods shipped between the 2 cities by truck and air, which is about $14 billion worth of goods, 4.3 million tons. Also in Cleveland, there's a lot of manufacturing jobs in transportation related industries, and which are key partners, which would be key partners in the Hyperloop construction. Next slide, please. And then also this sits right, in the Great Lakes mega region. which, as you probably all know, is, the largest in America. It's over 55 million population, and that was in 2010. So we'll see what happens with the new census. It's trillions of dollars of GDP. Sorry, I don't like to say that. Which amounts to about 17% of the U.S. GDP. It's, large. Canada also contributes to this mega region, with Toronto adding alone about 5.5 million people and $258 million of GDP. Next, please. So let's go on to the feasibility study. Next, please. So as I mentioned earlier, NOACA was responsible for 50% of the funding. So we had funding partners. So the Cleveland Foundation, Richard King Mellon Foundation, Ohio Department of Transportation, and the Ohio Turnpike were all funding partners in this project. Next, please. And we also had collaborators, which included all the MPOs along the route, including TMACOG, Federal Highway, Illinois Department of Transportation, NASA, Indiana Toll Road, and many others. So we had a lot of support for this project. Next, please. So the project scope was basically 4 phases, which were objectives and organization, site reconnaissance and preliminary route analysis, technical and financial feasibility, project development cost and schedule. Next, please. So the 3 route options. First, let me apologize for the map here. It got a little, I'm not sure what happened, but the routes are not in the middle of the lake. Cleveland does not sit in the middle of Lake Erie, so excuse the map here. I'm not sure what happened, but anyhow, we looked at 3 representative routes, and then we looked at 2 routes between Cleveland and Pittsburgh when we added that on. So the first route was the straight line route, which was really more of a conceptual route. And so what we looked at is what was the straightest line possible we could get between Cleveland and Chicago. But this also required the route to go under Lake Erie and Lake Michigan. So really, we just looked at this as really a conceptual route and didn't really give it as much analysis as the other 2 routes. So then we also looked at the toll road route, which initially we followed the Ohio and Indiana toll roads, right along the right of way, but that proved to be too curvy for Hyperloop. Hyperloop really needs a straight line to really get up to top speed. And so then we looked at having to move kind of off of the right of way a little bit, following the toll road as much as possible. But in some sections where the toll road was more curvy, the Hyperloop went straight. And then the third route was a hybrid route, which we looked at the straightest right of way on the toll roads, straightest right of way on a railroad right of way, and then some. And then in the first 2 routes, we looked at stops in Toledo, South Bend, and Chicago. But the hybrid route is skipped South Bend. And then the 2 routes between Cleveland and Pittsburgh, we looked at one that started in downtown Cleveland, went through downtown Youngstown, the Pittsburgh airport, and then Pittsburgh downtown. And then the second route we looked at started at Cleveland Hopkins Airport, went through North Lima, and then to downtown Pittsburgh. Next, please. Next, please. Well, I'll just start talking about it. Okay. So I did include a couple of route timetables in here. So I'll just highlight the Toledo for you. So depending on which route you take, between Toledo and Chicago is between 24 and 31 minutes. Toledo and Cleveland is between 17 and 19 minutes, and Toledo and Pittsburgh is between 34 and 35 minutes. Next, please. The next one is it's just looking at the two different routes between Cleveland and Pittsburgh. And this one, the Cleveland and Toledo to Chicago or Cleveland are the same, but to go to Pittsburgh, you save a couple minutes. So otherwise, it's the same. Next, please. Now I'm going to get into some of the results of the study. So this here is looking at the regional economic impact, and all of this was done based on the toll road route, which is around 469 miles and costs about 25 billion to build. So looking at this, the employment growth is 900,000 plus person years in all sectors. Income increases almost 48 billion. Property value increases almost 75 billion. And there's also some tax benefits. So local income tax would increase 2 billion, federal about 9.4 billion, property tax 1.3 for a total of about almost $13 billion of tax benefits. Next, please. The next one really just highlights the same thing I just said, so we can even skip that one and go to the slide after that. Can you keep going one more? Yep, great. So it's well, I'll talk about the job creation opportunities. It's on the previous slide. So there are significant effects on number of markets and industries that provide secondary revenue opportunities, and like raw materials, advanced technologies, transportation companies, energy companies, media companies, entertainment, landowners, engineering, government. There's a lot of benefits, not just for exactly the Hyperloop, but there's a lot of opportunities surrounding the Hyperloop as well. Okay, next, please. So this is talking about the freight. So we not only evaluated passenger forecast, but also freight forecast. So for Hyperloop, although Chuck did mention what's going on in Hamburg, but for this route, we really didn't look at the bulk freight. We looked at more high value freight, things like electronics, pharmaceuticals, precision instruments, things like that. And we were looking at same day parcels, air cargo, and less than truckload. And as you can see, like air freight is pretty expensive. It's $4.63 per ton mile. Truck is 0.37 or 37 cents rather, and Hyperloop is 10 cents. So Hyperloop is very competitive against air or truck shipping. It's not so much against rail, but so rail would continue to do bulk freight, where Hyperloop could take a lot of this more high value freight. And I'm sure, as you all know, same day parcels, Amazon, UPS, FedEx, drive down the freeway. I was driving to Columbus a few weeks ago, and I swear every single truck on the freeway was either Amazon, FedEx, or UPS. And so hugely growing market, and Hyperloop is really poised to take a lot of that. And here it says express trucking demand is expected to grow 4 to 5% per year, which is pretty significant. Okay, next, please. Chuck already sort of went over this, but I'll just highlight it again. Hyperloop is emission-free. So, we forecasted over the next 25 years that we would reduce the carbon dioxide emissions by 143 million tons. So that's pretty significant. And then next, please. Once we had completed the draft study, we really wanted to make sure that this was, all of our assumptions and our work was checked by a peer review panel. And so the aim of the peer review process was to assess areas of strengths and weaknesses in the feasibility study, and to provide guidance on factors that may need to be added to the analysis or any alternative approaches that we didn't think of. and the effectiveness of the analysis and meeting the requirements of both state and federal governments. So we just thought that was really important to validate that what we did was, good. And then next, please. The peer review panel consists of participants from Cleveland State University, University of Illinois, Chicago, Northwest University, and Carnegie Mellon. We wanted to try to hit all of the cities that the Hyperloop corridor is going through. And then next, please. The last slide really is just a snapshot of kind of a lot of things that I've already talked about. Some of the things are the financial return, the economic return, which Alex Metcalf will talk more about that. So, but everything else I think is on here. 25% travel demand increase over the next 30 years, 31% of the travel demand market captured by 2030, 4.14 passenger and freight operating ratio, which is really great. Already talked about the 10% per ton mile for freight compared to 4.63 for air. The employment growth, capital costs, the income increase, the property value increase, which is really significant, the tax base increase. And also, it is a profitable endeavor for anyone who would want to invest in that. And last slide is just where you can look at the full feasibility study if interested. Here's a website. If you have any questions that you don't think about today and you want to email them to me, feel free. There's my email. And thank you for having me. That's it.
Thank you so much, Kathy. Fascinating. And there are some questions.
Okay.
So will the Great Lakes Loop be part of a national loop? Florida, New York, the West Coast? Good question.
Well, that's our hope. This is really just kind of like phase one. We have a map, which I think maybe is in someone else's presentation of potential other corridors. We really want this to be a system. So, connecting the East Coast to Florida, to Canada, to the West Coast eventually. It would be just a whole system, kind of like the interstates.
And on the Great Lakes Loop, the question is, could construction start here in Toledo?
I suppose it could. I mean, as long as it makes sense, we have to, as Chuck mentioned, you really have to have an origin and destination. So if it was constructed between Cleveland and Toledo, perhaps, or Toledo and Chicago, perhaps, so you made a logical connection where people and freight want to go. So it's possible.
Also, someone wants to know the affordability and sustainability with respect to the conventional railway network.
Well, I'm not sure I understand, but it doesn't take the place of rail, if that's really the question. There is still a place for rail, as I mentioned. They can still deliver freight, bulk freight at a lower rate. If you're not worried about speed, the train is still very valid. It's still valid for a lot of things. But my opinion, I think, Hyperloop is superior to high-speed rail. So, in my mind, I would support the Hyperloop over high-speed rail.
And how can this potentially affect communities nationwide? Because as we just saw there, you could live in Toledo and work in Chicago and be home in no time.
Well, yeah, it can make, cities, like neighborhoods rather than, I live in Cleveland or I live in Chicago or I live in Toledo, Chicago. You literally could live in another city and work in another city. So it really makes kind of like a huge neighborhood, in a sense.
One more question. Do we see technology exports to developing countries? Hence the above question of affordability and sustainability. So this is coming from one of the people who is tuned in and watching.
Well, as far as the Hyperloop corridors are being studied all over the world. There's other places in the United States where it's being studied as well. Different companies. There's a few major Hyperloop companies. We've been working with Hyperloop TT, and of course they have also many other things going with other countries. As I mentioned, they have their commercial track that they're going to be building in the Emirates. So there's a lot going on in the world. So I think whoever builds first, I think everyone will learn from that.
All right, thank you so much.
Okay, thank you.
Interesting. Our next guest is David Gedeon. Dave is the Vice President of Transportation for the Toledo Metropolitan Area Council of Governments. He is responsible for all aspects of TMACOG's transportation planning program. During his 22-year career with TMACOG, Mr. Gedeon worked with the Environmental Department, led the Growth Strategies and Commuter Services Department, and has served in the Transportation Department since 2004, where he's operated as VP since 2014. He proudly holds a Bachelor's and Master's of Arts degree from the University of Toledo Department of Geography and Planning, and he is a certified planner with the American Planning Association. Welcome.
Thank you, Lisa. It's a pleasure to be here. I'd like to thank the University of Toledo and AAA of Northwest Ohio for inviting me and allowing me to share some of my insight onto this topic. Next slide, please. So what is TMACOG? If you're not familiar with TMACOG, we are the Toledo Metropolitan Area Council of Governments. Similar to NOACA, we are the federally designated metropolitan planning organization for our area. And our area covers Lucas and Wood counties. Click it again, there we go. Lucas and Wood counties in Ohio, and we also cover the southern portion of Monroe County in Michigan, the southern 3 townships plus Luna Pier. Our responsibilities include transportation and water quality planning. We represent a population of just over 600,000 people, so slightly smaller, significantly smaller as it goes to NOACA. As I mentioned, we cover 2+ counties. Within that are 11 cities, 27 villages, and 33 townships. So plenty of bosses to give us projects and let us know what interests them. We develop our region's long-range transportation plan. That is currently the 2045 plan. We just updated that, so we identified as Update 2020. That plan was just approved in...
my part, so I'm done. I think I still have to be part of the panel at the end.
I believe I still hear somebody. There's somebody else that I believe needs to mute. Thank you. So our current plan is our 2045 plan, Update 2020.
Okay, should I open the windows?
I still hear somebody talking. We also manage funding for federal aid projects within the Ohio portion of our planning area. Next slide, please. Thank you. So TMACOG's participation in the Hyperloop project began a couple of years ago. As NOACA was beginning their feasibility study and getting partners on board, they contacted us and other MPOs that are along the Hyperloop corridor and asked us to become a collaborator with them. We signed our letter of intent in 2018. We held a stakeholder meeting last year, on almost a year to the date, October 17, 2019, to disseminate information on the Hyperloop feasibility study and to get some local feedback from the stakeholders and attendees. At that session, we had about 40 attendees and gave us some very good feedback, asked some very challenging questions, and had a very good dialogue. Next slide, please. So why Hyperloop and why Toledo? As has already been mentioned, Hyperloop is a truly transformative technology. Chuck noted that we haven't seen a new, truly transformative form of transportation in well over 100 years. And having Hyperloop, start to take shape and be developed, and also, have a route that would go through Toledo is invigorating for the region, I believe. This is something that, as I note below, it's logical and essential for Hyperloop to be located in Toledo, and I'll get into some reasons why I believe that is. We're a critical north-south link in the transportation network, and having a Hyperloop station in Toledo would facilitate some of that north-south travel. And as I'll explain in a few moments, Toledo is a significant transportation and logistics hub. We have a lot of distribution and logistics companies here, and Toledo would be a logical location to take advantage of some of those opportunities that would be presented. Next slide, please. As I mentioned, and we've discussed, Hyperloop is a truly transformative technology. With an average speed of 500 to 600 miles per hour and a top speed of over 700, you're looking at travel at ground level comparable to air. As was also mentioned, you can get to Cleveland in about 20 minutes, Chicago in 30, and Pittsburgh in approximately 40. That would enable people to live and work in Chicago and vice versa, to travel to Toledo and work or live here. Same thing with Cleveland. I'm already familiar with some people that work in other companies that have been commuting weekly from Chicago to work at Toledo employers. They're buying or either buying a home or renting an apartment or a condo and doing the weekly drive back and forth. Imagine if we had Hyperloop and they wouldn't need to do a daily commute. They could get to their job much more easily. Hyperloop transports over 160,000 passengers per day and can move about 4,000 cargo shipments daily. And the cargo is what I'm going to begin to get into a little more detail on now. Having the convenience of Hyperloop transporting every few minutes offers much greater flexibility than airlines or rail service can provide as well. Next slide, please. So Toledo is a critical north-south link in the transportation network. This map here is focused on primarily Northwest Ohio, and shows the TMCOG portion of the national highway system. So in red, you've got your interstates. In blue, you have other NHS, National Highway System routes, U.S. routes, and state routes. But there are a few locations in the nation that have as advantageous of a geographic location as Toledo does. There are few cities that have direct access to both north, south, and east, west, but Toledo is one of them. And the map shows that with our robust transportation system. Also in green on this map, you can see some of the National Highway System intermodal connectors. So what we don't show on this map, however, are some of the numerous rail assets that we have in Northwest Ohio. Northwest Ohio is the crossroads of four railroads: Norfolk Southern, CSX, Canadian National, and the Wheeling and Lake Erie. We have several intermodal facilities also located in our region, including CSX's Northwest Ohio Intermodal Terminal in North Baltimore, and also the CSX National Gateway. That's also part of the CSX National Gateway project, and Norfolk Southern's Airline Yard, which is located in the city of Toledo, just south of the University of Toledo campus. Next slide, please. This map shows the percentage of daily commercial traffic. The Ohio Turnpike carries between 30 and 40% of the commercial traffic from Maumee to the east. Commercial traffic increases to over 40% west of Maumee, due in part to lower passenger volumes. But I-75 through Ohio and, through Lucas and Wood counties averages about 23% commercial traffic. Thinking about it nationally, the I-80-90 corridor, the Ohio Turnpike, and I-75 are on the short list of national freight corridors that carry greater than 8,500 trucks per day. Next slide, please. As Kathy alluded to previously, this is essentially a network map of what is conceived for Hyperloop. and in particular the Great Lakes Hyperloop system. So highlighted in green is the proposed Pittsburgh to Cleveland through Toledo to Chicago Hyperloop route system. That is identified as their phase one and primary cities. If you look on here in blue, you've got a phase two, and in orange, you've got a proposed phase three. So this system, would connect not only Cleveland to Toledo to Chicago, but also give you travel east-west, north-south, allow you to get all the way in this proposal to Minneapolis, Des Moines, St. Louis to the west, and the key Atlantic corridor, Boston, New York, Philadelphia, Washington to the east. You can see in the blue the line that would go north-south, making Toledo that critical connector to be able to get from Toledo to Detroit and parts north up into Canada, to Toronto and all the way up to Quebec, south to Dayton and Cincinnati. So, as another transportation network, Toledo would play a critical link in the establishment of a solid network of transportation options. Next slide, please. Toledo is a intermodal transportation hub as well. On this map, you can see the various intermodal terminals, distribution centers, distribution hubs that are located within the region. There are others aside from what we show here, but these are some of the primary ones. So there is a lot of distribution of freight and goods through the Toledo area. Of course, the construction that's currently going on with the Amazon Distribution Center and the Amazon Delivery Hub in Rossford and Toledo, respectively, it just exemplifies how Toledo has grown in prominence, and Northwest Ohio's grown in prominence as a freight distribution hub. Hyperloop is a technology that, if you're looking to move high value, time sensitive product and goods, Hyperloop is going to be a critical piece that shippers can take advantage of and expand their business opportunities. Next slide, please. I'm going to take a moment to talk a little bit about another opportunity that our Northwest Ohio businesses can take advantage of too, coming up soon, and that's going to be the Gordie Howe International Bridge. Currently, the Ambassador Bridge and the Windsor Tunnel transports the volume of trucks and passenger travel between Detroit and Windsor, Canada. This new bridge would provide an expedited route via the additional customs booths, the expeditious scanning of goods through the truck traffic. It would make it a much more viable option for trucks to expand operations because of the time savings that the Gordie Howe Bridge would provide. This is a conceptual image of what the new Gordie Howe Bridge would look like. Next slide, please. So based on its current schedule, the Gordie Howe International Bridge is expected to be completed in 2024. In total, the bridge itself, the United States and the Canadian ports of entry, and the Michigan interchange to I-75 is a $5.7 billion investment. 25% of the trade between the United States and Canada flows between Detroit and Windsor. The primary crossing is currently the Ambassador Bridge, as I mentioned. That structure currently carries about 2.5 million commercial vehicles per year and 4.6 million passenger cars per year. Truck transport roughly equals $120 billion in goods annually. The Detroit-Windsor Tunnel carries a large amount of traffic, just under 4 million cars per year, but only about 20,000 trucks annually due to size restrictions. Based on statistics from the Ohio Development Services Agency, Ohio was the 9th largest exporting state in the nation in 2019. Ohio exports to Canada total about $20.5 billion annually, and that represents 39% of the state figure. The image on here shows shows a rendering of the United States port of entry. You can see the number of lanes that will be available for customs checks, and that's going to greatly expedite shipping through through and across the U.S.-Canada border. Next slide, please. Gordie Howe Bridge is going to have 3 lanes of travel in each direction. Canadian Port of Entry is going to have 24 inspection booths, 16 toll booths, which will handle the tolls for both the U.S.-bound and Canada-bound traffic. The United States Port of Entry is going to have 36 inspection booths. Last week, TMACOG held a TMACOG tech session that discussed discussing economic development opportunities. The Gordie Howe Bridge was a prime discussion topic at that session. Developers, shippers, and distribution companies are already strategizing ways to take advantage of the increase in commerce that the new bridge is expected to induce. Hyperloop can be a significant attraction factor for firms looking to locate in Northwest Ohio and Southeast Michigan. Hyperloop would be an ideal fit for high-value, time-sensitive goods delivery. Next slide, please. This here is a rendering. You've seen this previously in Chuck's slides, but it's a rendering of a Hyperloop station. While the Hyperloop station, may be similar to, an airport station in some respects, it's going to pose unique challenges to communities and transportation providers and roadway planners that we're going to have to study hard about, give a lot of consideration to, and figure out solutions to. Next slide, please. So here I try to identify a few of the local challenges. There are going to be a significant number of challenges that would be presented to any region that is having a new technology of this type. So some of the local challenges we would look at would be improved connections for freight movement. So considering the opportunities that Hyperloop will present for shippers and distribution companies, improved freight connections may be needed to improve movement in and out of the Hyperloop station. Connections to existing roads may not be adequate to handle the increased traffic volume, so planners and engineers will need to reevaluate roadways for both capacity and safety. That can include the last mile connectors to and from the facility. Transit options will also need to be expanded to allow elderly and disabled individuals access to the station as well. So, for example, in the illustrations that we've seen, a proposed Hyperloop facility in Toledo could be located at or near the Toledo Express Airport. Presently, public transit does not serve that portion of Western Lucas County. So transit services would need to be expanded to make that station accessible to all users outside of the existing transit served area that could be selected if they're looking at a Western Lucas County site. Additionally, there may be some highway system impacts to the highway system that would be needed to accommodate Hyperloop as well. The location of the station would be expected to generate additional commerce and commercial and residential development, and safety or capacity concerns will be needed to address on local as well as interstate highways. The Hyperloop feasibility study identifies that a significant degree of transit-oriented development is very likely to occur in the vicinity of the station. And Kathy alluded to that, and I believe that'll be part of the discussion with Dr. Metcalf in a few moments. But if the station were located in a rural portion of our region, that's going to present some very unique challenges for local land use planners, especially considering that, as we all know, that portion of Western Lucas County is the Oak Openings area and is one of our crown jewels in Northwest Ohio with its species diversity, both plant, animals, and so forth. There will be other construction challenges that will be facing us from an infrastructure standpoint as well. And we'll need to do all that we can do to consider those and come up with the solutions that'll be needed to not only make this a productive location and productive system for ourselves, but also protect the environment, and be able to take advantage of some of the commercial residential opportunities that could be presented here. So all that said, challenges of this type are likely to result in a lot of economic opportunities, and we're ready to step up to that challenge. So next slide, please. So very much. On this slide, you've got my contact information, phone number and email. So feel free to email me with any, and with that, I will turn it back over to our moderator. Thank you.
Thank you so much, Dave. Really fascinating presentation. So much information, a lot to learn here. Appreciate your time. We are going to now take a break for a couple of minutes with a little intermission, and then we're going to continue with our panel discussion and question and answer session of the program. Now, if you have any questions for the previous speakers, please feel free to type them in the chat session at this time. We'll see you in a few minutes. Thank you. Welcome back, everyone. Now we are going to meet our panel. In addition to our featured speakers, who you just heard, we are pleased to welcome Dr. Alexander Metcalf, PhD, President of Transportation Economics and Management Systems, Inc. It's an internationally renowned expert in transport economics, demand forecasting, transportation modeling, and systems development. Dr. Metcalf was chief economist with British Rail, lead economist on the mainline electrification study, cross-country services study, and Channel Tunnel. He was responsible for the planning for the rail airport connections studies between Heathrow Stansted Airport and Gatwick Terminal 2 projects. Now, prior to joining British Rail, Dr. Metcalf worked for EEC and was the chairman of the technical steering committees for European passenger study. Now, since moving to North America, Dr. Metcalf is focused on implementation studies that provide accurate and reliable demand and revenue forecasts, operations and capacity analysis, economic impact assessments, financial analyses, and business plan development. He has developed a number of new approaches to transportation modeling, including the use of stated preference survey techniques in demand forecasting and the practical use of the economic rents theory to assess the supply side economic benefits of projects. Dr. Metcalf holds a PhD in transport economics and a BS in economics from London University. Welcome, Dr. Metcalf.
Thank you very much. It's an honor to be here. Okay, thank you very much. We'll begin with the first slide, and I want to go back to one of the early slides that Chuck Michael showed. When we began to think about this Hyperloop study, essentially one of the things that we were aware of was that it was not just an evolutionary transportation system, but a revolutionary transportation system. And if we were going to develop a revolutionary transportation system, we had to be extremely careful to make sure that we analyzed it in the most effective way so that we did not end up with a situation where we had a lot of questions left at the end of the day as to the business case for developing the Hyperloop system. We were very lucky that NOACA decided that it would hold technical advisory committee meetings on a regular basis throughout the work, which basically allowed a lot of questions from experts, from the toll roads, from the DOTs, from the various transportation institutional organizations that basically make up the transportation planning community in Ohio, Pennsylvania, and also Illinois. So there were regular meetings throughout the study that helped gave us information that we could use to make sure that the study was really covering all the bases and that there were no fatal flaws associated with the work. In addition, Kathy mentioned that basically we held a peer review in which we asked the real experts throughout the corridor, the academic experts at universities like Northwestern, Cleveland, and the Carnegie Mellon Institute in Pittsburgh. So we are very fortunate to have a lot of input to check and evaluate the results and consider the fact that we were implementing a revolutionary system. In terms of the study, there are just a couple of comments I want to make that may not be obvious to everybody from the presentations we've had. Chuck mentioned that we were using a 4-meter tube for Hyperloop. Now, you can put a 737 fuselage through a 4-meter tube, but you can't put a high-speed rail through a 4-meter tube. For high-speed rail, you need a 10 to 12-meter tube, which is a much bigger tunnel. And as a result, the cost would be considerably higher. So Hyperloop actually is a revolutionary system in the sense that its costs for building the tubes, certainly for a cut and cover system, were really relatively competitive. Another feature that we need to think about is that the freight traffic we're moving in a 4-meter tube could not be the big boxes that the freight railroads carry. They would simply not fit into that tube. Their dimensions are too big. So what we looked at was the high-value freight. Now, high-value freight is a revolutionary traffic. 10, 15 years ago, it was really a sideshow in the overall freight business that was concentrating on containers and the movement of traffic across America by basically the freight railroad system. But today, the real money in freight is in the parcel and express freight business. The express freight business and e-commerce is growing at 15% a year, creating massive growth in the parcel traffic and the kind of traffic that UPS, FedEx, XPO, and a whole variety of freight truckers are currently moving. As a result, we have a cost-effective construction cost, and we also have, as well as our passenger traffic, a high-value freight product. In terms of the impact of all this on our results, if we can go to the next slide, we'll basically see is that for the first time in my experience in carrying out high-speed ground transportation studies in North America, and since I came here in '86, we've done over 100 of them, is that we produce a positive financial return on investment. That's a revolution. And basically, while the 4 to 6% return on investment that we found from those studies, in these studies, was basically a good return, it's not the kind of fantastic return that a Fortune 500 company would go after. But if you ask the hedge funds, if you ask the investment banks, and if you ask the teachers' pension fund, they're all going to want to pick up that kind of investment. I can actually get a mortgage on my house today between 2 and 3%. So a 6% return on investment is really good. That is a revolutionary result. And basically what we're seeing is that there's a great opportunity for the private sector as well as the public sector to participate in the development of Hyperloop. In terms of the cost-benefit analysis, we were very careful to follow US DOT FRA criteria very carefully in making the assessment. And again, we came up with very significant cost-benefit ratios at both 3% discount rate and 7% discount rate. Now, 7% is really a way to discourage you from building infrastructure because basically it says that, you can only borrow money at 7%. Well, we all know that you can, even I can borrow money at 2 to 3%. So a major infrastructure project would certainly be able to borrow significant money at 3 or 4% quite easily. So we've got a really strong financial and economic result coming from the business case that we developed with NOACA and HTT. Next slide. Next slide. Okay, Kathy has already gone over the supply side benefits of Hyperloop. Clearly, we saw considerable employment, income, and property value benefits flowing from the development of the system. Not only that, we were going to produce something like $12 billion of extra tax money for the government. So if the government were to invest $9 billion into a project like Hyperloop, it would actually get the money back over the 25-year life of the project through the extra taxes that it would get from the increased incomes that individuals would earn as a result of basically building the system. So I think what we're saying is that there is good reason for government to invest in basically this system, and it will create a lot of jobs, a lot of income, and a lot of property value through the corridor. And I want to basically go to that $75 billion of property development across the corridor, because it's a very large number. We're going through a revolution, but nonetheless, people want to know, is that really real? So if we could go to the next slide. I want to show you, and you can look this up on your computer. You can go and look up King's Cross Central Development. British Rail, we built a 150-mile-an-hour system from King's Cross Station in London, a city of about 7 or 8 million, quite similar to Chicago in many ways. We built it 400 miles to Edinburgh, a city of about 2 million, very comparable in many ways to the Chicago to Cleveland corridor. And as a result of building a 150-mile-an-hour system, basically what happened was they have generated at King's Cross a TOD development of $16 billion. And it says, 25 large office buildings, 20 new streets, 10 public spaces, refurbishment of historic buildings, and 2,000 new homes, all within that development that is there at King's Cross Station. So if we're going at 400 miles an hour, not 150 miles an hour, with this revolutionary new technology, it would seem reasonable that in Chicago, we could be talking about a $27 billion development at both downtown Chicago and also at Midway Airport, if we connect the Midway Airport in, which we would do. And in Cleveland, we could be talking about $15 billion development, similar to what you see for King's Cross. So as a result of this, in Toledo, we're saying Hyperloop station built out towards the airport, and build it out towards the airport because of all those freight connections that we've heard of from David. Then basically we're looking at about $5.2 billion worth of new development and new economic growth that would be stimulated in the Toledo area. And with that, thank you very much indeed.
Thank you so much. More incredibly interesting information. Finally, we're going to welcome Gary F. Thompson. Now, Gary is a CPA and Executive Vice President for Regional Growth Partnership. He has a career that has ranged from accounting to sales to economic development. He began his career as an accountant in public service and then private industry for several years before he began to work in sales for a large architectural and engineering firm in Toledo. Mr. Thompson was recruited to an architectural firm in Farmington Hills, Michigan, where he worked in business development. Returning to Ohio, he joined the Oregon Economic Development Foundation, where he worked for 5 years. In 2011, Mr. Thompson was recruited to join the Regional Growth Partnership and manage the Jobs Ohio program for Northwest Ohio. He is the past marketing chair of the Northwest Ohio Regional Economic Development Association and the past chair of the Toledo Metro Area Council of Governments Communications Committee. Mr. Thompson currently serves on the board of the Industrial Asset Management Council Membership Committee and Central Catholic High School. In the past, he has served on the board of the Ohio Economic Development Association and has been an elementary school volunteer tutor and instructor for junior achievement and a Little League coach. Today, he is mainly a constructor of theater sets and a home remodeler. Now, Mr. Thompson has been published in Athletic Business Magazine and Michigan Construction News. 2014, he was recognized by Consultant Connect as one of the top 50 economic development professionals in North America. Mr. Thompson is married to Dawn, an educator, and together They are raising 3 young men, Alec, Owen, and Evan. Mr. Thompson is a proud graduate of the Morrison R. Wade High School and the University of Toledo. In 2017, he was inducted into the Morrison R. Wade High School Distinguished Alumni Hall of Fame. Welcome.
Well, thank you, Lisa. I also want to thank the University of Toledo and AAA, not only for this series and seminar that they put on, but for being a great economic development partner as we execute projects throughout our 17-county region that goes from Lima, Ohio, through Toledo. And we do work with those bordering counties in Michigan as well. So happy to be here today. I have 4 quick points to make about the economic impact of the Hyperloop. And I think what Dr. Metcalf forgot about that King's Cross station is it has that connection to Hogwarts, where we don't think we would get that in the US. So it might spur a little extra additional economic development. This has been an amazing presentation today, I think, of exciting, what I would call transformative technology. And that word has been used a few times. If I think about my lifetime, and I wasn't around for all these, right? But certainly the automobile was transformative. The railroad locomotive was transformative. The airline or the airplane was transformative. And a lot of those industries and transportation modes had connections to Ohio and still to this day. But if you just take a broad point, what does that transformative technology do to a region? Well, Chicago, New York, I would venture, right? The railroads built those towns. Pittsburgh in some ways as well. Detroit is home of the automobile. Seattle, Washington, home of Boeing and really the industry of the airlines. But in Ohio, you have Wright-Patterson Air Force Base in Dayton, the single largest site employer in the state of Ohio. So it really does have an incredible impact on the region where these types of transformative technologies take hold. And I think people should just be aware of that. Setting aside the coronavirus and COVID-19 and all the health problems that come with that, the number one economic development issue, topic of conversation is really still workforce. And it comes both in quality and quantity, right? How do I get enough workers to fill my factory? I could start a new shift, a third shift. And how do I get workers with the right skill set? Those are the 2 important items in the area of workforce development. And we've heard a lot of people allude today, I could live in Chicago and work in Toledo. And that's absolutely true, right? Something like the Hyperloop would open up access to the populations of Detroit, Chicago, and Cleveland to solve Toledo or Northwest Ohio's workforce problems. And that's a great opportunity. However, the reverse is also true, right? There could be a wonderful group of people living in Toledo, enjoying our metro parks, our wonderful quality of life, our affordable quality of life, our non-existent traffic jams at 5 o'clock, and get on a Hyperloop train every morning and go to Chicago to go to work and come home. So that cuts both ways. And I think, however, Northwest Ohio is poised to take advantage of that versus being a victim of that. So it's an incredible opportunity to help solve one of the economic development's greatest problems and issues at the time. The gold ring when it comes to transformative technologies from economic development perspective is landing some of the manufacturer, R&D, service and maintenance companies and businesses that would be essential to constructing and operating a Hyperloop train, right? So if Northwest Ohio or Cleveland or, dare I say, South Bend were to become the place where the trains are manufactured, where the track is manufactured, that region becomes identified with that technology. And it creates a lot of jobs, generally very good paying jobs and very jobs that take lots of skill, sometimes, through labor trade schools, other times through higher education. So it creates a demand for lots of training in the area and lots of expertise. So that's very important. Generally leads, and you've heard it today, to great wealth creation, both for individuals and communities. So that's an important item to take advantage as well, and really is the gold star for landing these transformative technologies. Down the road, the final point I want to make is when a region becomes associated with transformative technologies, success often begets success. So other companies, other entrepreneurs, other smart people with great ideas say, wow, if they can do that in the Midwest, if they can do that in Ohio, if they help develop the Hyperloop, maybe they can help develop my technology, my company. I know there'll be partners in that region that can help me do the things that I need to do to grow my new technology. And it becomes a self-feeding circle, if you will, of kind of new technology just grow. I mean, that's what happens in Silicon Valley. I think that's what you've seen, with Microsoft as a company, wherever they kind of put roots down, with Google as well. So it's a self-fulfilling prophecy that once you start to be known as a great technology region, you're going to always continue to attract new technology and new investment, and you keep that life cycle of economic development happening. So Lisa, those are my comments. They're brief. I didn't even prepare any slides. So I want to get you back on the screen and turn things back over to you because I'm looking forward to questions in the panel discussion.
What an impressive lineup of panelists today, and how lucky we all are to be able to speak with all of you and ask questions. One question that's coming through quite a bit is, and anyone can chime in and answer this, what's the timetable for this potential project?
Maybe I can take a shot at that one. That's a really good question. The timetable is dependent on several things. One is the regulatory process that we have to go through, and the other is public acceptance of a project like this, which takes a great deal of outreach and communication and information. So I think we're starting right now with the regulatory process, and once we wade through that with the federal government and with the various states and the departments of transportation, we should have a much better answer to the question. But we could start construction in as little as 2 years if things go right.
Another question that anyone can answer. With the current infrastructure continuing to deteriorate due to a lack of adequate funding, how do you prioritize this effort with existing transportation needs, including preparation for connected and autonomous vehicles? Also, will equity issues be considered in the development of this kind of transportation solution?
I can answer from the perspective of just Hyperloop. As our demand increases for transportation resources, whether it's Interstate 80 and 90 or otherwise, the expansion of those resources is going to take primarily public dollars if we follow the course that we've been on. It's our hope that we can see the Hyperloop financed privately without reliance on public agencies, and perhaps working in a public-private partnership when it comes to the stations. And that would allow the expansion of the demand and supply of the capacity without having to tap the public checkbooks.
This question is for Dr. Metcalf. This person says he brought out two important points of the tunnel diameter as compared to high-speed rail and the high-value freight. Both factors would make a lot of sense when we compare the maintenance and safety costs associated annually as compared to other model services. Can you help compare and put some perspective on it? Thank you. That was a question for Dr. Metcalf.
Oh, hi. Okay, yeah, we're just saying that basically the 4-meter tube is really an important factor, because basically for high-speed rail, if we were to build a tunnel, we would need, like the Channel Tunnel, which was built, we would need a 12-meter tube. The cost of tubes goes up exponentially with the diameter, and as a result, using a 4-meter tube, which you can put an aircraft frame or a Hyperloop down, means that the infrastructure costs are significantly lower as a result of being able to use that tube. So when we compare it with high-speed rail, what we're looking at is a significantly lower capital cost for the project than what we would face if we were to build a 220-mile-an-hour high-speed rail system between those three cities. With respect to the freight industry is really important to any private sector initiative, because while passenger traffic is looked on slightly dubiously by Wall Street, the freight traffic is looked on very positively. So the fact that we are generating significant revenues out of high value freight, which is growing very fast, will encourage the potential investment of people like Amazon, UPS, and FedEx into the system. Then basically what you're looking at is a completely solid kind of developed infrastructure that essentially Wall Street would buy. If we only move freight in Hyperloop, where basically Wall Street would be ecstatic about the ability to invest in it. You have to remember that kind of freight is the freight of the future. It is growing at a massive rate. People like Federal Express and UPS have to double their infrastructure at less than every 10 years. So when they look around and see what infrastructure they have today, they have to look at it and say, wow, we're going to have to double this in under 10 years. So the Hyperloop solution is really very, very important to them, because whether we like it or not only have we got the existing traffic on the highways, but we are going to have a very significant growth of traffic, 30 or 40%, which essentially means that you would if you didn't build Hyperloop, you would have to go out and build new infrastructure like new interstates. You'd have to widen your highways to 6 lanes instead of 3. You would really have to make significant public investments. Hyperloop not only could be funded by, or largely funded by, the private sector, but it would actually be a more efficient investment than basically investing in extra lanes on the interstate system or building new airports to accommodate the movement of express freight. So thank you.
Thank you so much, sir. And I'm going to combine a couple of questions here. One person says, it seems like a critical component are the magnets. How are those manufactured? And is that something that can be done here in our region? Also, where will all the raw materials or tubes be produced? And what is the predicted life of the tube? What will be the predicted cost of the trip? And that's for all the panelists, all those questions.
I'll take the first couple up here. In terms of the raw materials for the tubes can be made out of a variety of materials depending on if it's an elevated section or if it's underground. If it's elevated, it would likely be either structural steel, or it could be high performance concrete, or it could be a composite. If it is underground, it would likely be more of a composite rather than steel, because we wouldn't need the structural properties. And if it's a tunnel, the tunnel itself is the structure, so there would actually be no tube inside of the tunnel. It would be a liner and some waterproofing and so forth. As far as the life expectancy of the tube, we're using a 100-year design life for any of the materials.
Lisa, this is Gary Thompson. I just comment, if you drive around Northwest Ohio, right, you'll find solar panel manufacturers. and you saw solar panels in the animation. There are steel mills, and because of our connection to the automobile industry, they're learning to make better, stronger steel. Cleveland Cliffs is here helping that process in Northwest Ohio. And we have several companies engaged in the carbon fiber material that are moving that through research and development. And so all those types of materials that Chuck talked about there are companies here today in Northwest Ohio with expertise in that material.
Another question for everyone, anyone who wants to answer. Have there been any studies done that measure consumer demand for Hyperloop?
Well, this is Alex Metcalf. The Great Lakes feasibility study measured the demand in terms of both passenger and freight for the in a competitive environment between air, auto, and rail for the corridors. So, are there competitive studies done? Yes, there are. There are more of them getting done. But basically, we feel very comfortable that even though this is a area that has typically been regarded as having quite a bit of risk associated with it, that having taken on board all of the advice and input from Ohio DOT, the turnpikes, and the universities, that we feel comfortable that the forecasts that we've made for the Great Lakes feasibility study are very reasonable, subject to the usual plus or minus 20% error. Thank you.
Thank you very much. This question is for Kathy. It looks like the cost estimate is $54 million per mile. What is included in that calculation?
Thank you for that question. I think, okay, 54 million per mile. Well, that would include everything from the tube to the capsule to the motors, the solar panels. Would include everything that you need to build the system.
They have another question for you as well. They don't see the regional transit authorities in the participating cities listed as partners, but they are assuming that they were part of the feasibility study.
Oh yeah, absolutely. And actually, you know, transit would be a huge component of making it work, you know, appropriately. You know, when people are traveling between, you know, say Toledo and Cleveland, you know, their destination isn't going to be the station. Obviously, they want to go somewhere else. So, you know, definitely, you know, transit is going to be a huge component. And I think, you know, it really expanded in Chicago and Toledo and Cleveland and Pittsburgh from what it is today.
Thank you. This question is for David. To what extent has the Hyperloop been part of the 2050 vision of sustainable urban development planning around the region?
I think at this point, the evolution of Hyperloop is still, you know, we're still trying to catch up with our planning on projects like this. I can speak directly to our 2045 long-range transportation plan. We have a few references to Hyperloop in there, and they're more along the lines of initiatives and studies, additional work that would need to be done to, you know, help our region prepare for it, than a project of, you know, saying, you know, constructing so many miles of Hyperloop infrastructure within our planning area. So we're not to that point yet. That may be something that we look at further when we're developing our next plan. But at this point, we haven't, you know, put any projects in there that would inevitably lead to construction. The Toledo-Lucas County Plan Commission is in the process now of updating their region, their land use plan. I couldn't speak to necessarily what they have considered at this point with the Hyperloop or any sort of development that would go along with it, but this would certainly be the time to do that.
Thank you very much. Another question we've gotten several times is, how many jobs will be created to operate the system? So anyone who wants to answer that is more than welcome to.
Okay, this is Alex. The jobs associated with the operation itself would probably be in the order of 3,000 to 5,000 jobs, direct employment with the system, and that would cover both the operational aspects of the system and also the administrative and management parts of the system. Hyperloop, like a high-speed rail, will need a management. It will need a marketing department. It will need security department. It will need operational people. There may not be drivers. There may not be attendants in the actual capsules, but there will be a significant staff that basically is associated with operating the system. So certainly you're looking at 3,000 to 5,000, depending on exactly the character of the final system. But you're looking at that order of magnitude. So it would create a lot of jobs, and it would create a good staff that's involved with not just the management operation, but the maintenance of the system and all of the kind of activities that we normally associate with a high-speed rail system. Thank you.
Thank you, and lots of questions about cost. How competitive will the passenger fares be on Hyperloop in comparison to traditional rail or air?
I'm not sure if Chuck wants to answer that, but from an economic perspective, we can, because of the affordability of Hyperloop, we can offer fares that are comparable or lower than the kind of fares that people are facing on Amtrak. So you might be looking at for fares in the 18 to 22 cents a mile for economy and for 35 cents a mile in terms of business. Amtrak on the Northeast Corridor is charging 30 cents a mile for economy and $1 a mile for basically business or premium travel. So very competitive with an existing ground transportation system like Amtrak. So lower than Amtrak fares is what's been assumed at this point in time. There is a possibility that the fare, and there would be, commuter discounts, etc., discounts for senior citizens and students, etc. But basically, we don't know enough yet about the potential revenues that can be obtained from both indoor and outdoor marketing, as they're named, as Chuck identified, the fact that the capsules are going to be wired with video and all sorts of other devices. The windows can actually be used as a screen for advertising, and it's not clear yet exactly how much revenue could be generated out of that. If there is a significant revenue from that, that could mean that the fares could be even lower than the fares that we are currently assuming, which are themselves lower than traveling on Amtrak. Thank you.
This question is for everyone as well. What are the difficulties any of you panelists have encountered when it comes to the decision makers to accept this completely new technology with its uncertainties and potential risks with a high investment?
I think I'd like to start on that one a little bit. Certainly, it's a new technology. The risk is a function of experience of design, construction, and operation. I think what you will see in the US is an example facility, a demonstration facility that decision makers can go and visit and see and feel and touch and ride so that they can get a feeling for not only the scale of it, but the comfort for the passengers and so forth. If it's funded privately, it's a little bit different reaction from the public decision makers if they don't have to invest any funds in there. I think there's a real opportunity for public-private partnership in many areas of the Hyperloop construction, especially in terms of stations. If we integrate a Hyperloop in with existing transportation resources, like bus stations, train stations, airports, whatever the case may be, there's a real economy there of not duplicating services. Other than that, I think the most common comments that we receive, anybody who's done a linear transportation project understands that right-of-way is probably the biggest challenge of all to communicate to residents and citizens along the way. I think it takes a high level of respect for people's land when you do a project like this. If we're going across a farm field, as an example, it's incumbent not to interrupt a farm plan and be respectful of that particular case. If we're going through a dense urban area, that's why we go underground, so that we don't have to remove any existing structures or relocate anything. And I think that goes back to having a lot of respect for the area that you work in. And I'll yield to other people if they have any other experiences.
Well, it's some of the experiences that I've had in talking with other folks about it is, I think there's a level of excitement about it. I went to a couple of conferences and workshops where there were virtual demos of Hyperloop and the technology. And people that have experienced that demo walked away with almost a giddy sense of excitement over the prospect of the technology. Now, if it were a matter of, our local electeds having to reach into their pockets and pull out some cash to the kitty to help fund it, I think some of the impressions might be tempered a little bit. But at this point, I think there's a real sense of excitement over the prospects that Hyperloop could bring.
I'd like to just add a little bit to that. At NOACA, throughout this process, we did a lot of public outreach, stakeholder meetings. We also had an open comment period on the study itself. And largely, we received really, really positive comments from members of the public, all very excited, as David mentioned, from his point of view as well. And we've also had a lot of conversations with the elected officials, and who also seemed pretty excited about the whole thing. And we do have some history. When the railroads were being built across the United States, so the towns that didn't have a rail station, were the losers in that. And so, everybody wants to be first, for this technology.
Yeah, this is Gary Thompson. I would say from an economic development perspective, there's two interesting things that are happening. One, most times when people approach local governments or state governments and elected officials with an idea like this, they invariably they're asking for $8 billion or something. I got this great idea. All I need is the money. This Hyperloop technology is, it's turned the table on that. They're coming to the table with a demonstrated pro forma that actually attracts private funding. And I think a lot of times that throws public officials for a little bit of a loop, no pun intended. And then secondly, as you start to build this type of infrastructure, or you get to zoning and planning hearings, right? It's not necessarily the farmer who's agreed to grant easement that's going to complain about it, but it's that farmer's neighbor, right? Who, hey, I don't want to look at that because when I bought the property, I saw a fence back there and I don't want to see something else. And it gets very individual very quickly. And as many have alluded to, we've had a lot of experience in Ohio getting these type of projects done, not only with railroads and interstates, but we've had some major pipelines come through the area lately. And I think Chuck said it very well. It all depends how you treat people. If you treat them with respect, listen to their concerns, I think generally speaking, the people in the Midwest see the value and we can reach agreement. Yeah, so they're interesting conversations, I think, that are being had that maybe have never been had before.
Thank you so much, everyone. Some incredible questions. A lot of learning going on here today. There are a lot more questions. We don't have time to get to them all, but a couple of the panelists provided email addresses, and I'm sure everyone would be willing to answer any questions that you may have. But what an informative afternoon. Thank you very much to everyone. I'd like to make one final introduction now for closing remarks by the AAA Senior Executive Vice President, Edgar Avila. Edgar.
Thank you very much, Lisa. Good afternoon, everyone. Thank you for joining us today to learn about Great Lakes Hyperloop and the potential impact on transportation and economic development in our region. On behalf of AAA Northwest Ohio and the University of Toledo College of Engineering, we want to thank the speakers and panelists for their excellent presentation, and to Lisa Guyton for her continued service as MC and moderator for Technology Takes the Wheel speaker series. And finally, to Patty Rilou and Diana Van Winkle from the University of Toledo College of Engineering for arranging this first virtual event. 3 years ago, AAA Northwest Ohio and the University of Toledo collaborated to develop a speaker series. Our goal then was to develop a forum to bring in industry experts to educate the public, transportation planners, government leaders, and elected officials on the future impact of autonomous and connected vehicle technology. Due to the success of the speaker series, AAA clubs began co-hosting similar events with other universities to provide education on smart mobility technology across the country. Today, we are in a new age of innovation that is moving at a rapid pace due to the unlimited imagination and creativity of engineers. The future holds the promise that smart mobility technology and Hyperloop as well can dramatically reduce traffic fatalities and injuries. However, even with new innovation, research from AAA Foundation for Traffic Safety shows drivers are assuming advanced driver assistance systems found in newer vehicles do not do more than what they were engineered to do. Drivers are relying on these systems more than they should, which can lead to deadly consequences on the road. As an example, the term autopilot does not mean the vehicle can completely drive by itself and that the driver can safely take their hands off the wheel and engage in social media on their cell phone. Until the day we can safely transition to self-driving and fully connected vehicles, AAA will continue to work with our partners in business, government, and higher education, like the University of Toledo, to educate the public on traffic safety and how to properly use smart mobility technology. In the meantime, please join AAA and consider doing two things that can save lives and prevent serious injuries. Always wear a seatbelt and drive distracted-free at all times. Thank you for your consideration to assist in this effort by driving safely. Lisa, back to you. Thank you for your time.
Well, thank you so much to Edgar and AAA for all they do to make this possible as well. I would also like to thank the speakers, the panelists, the honored guests, and our audience members today. Thank you to the co-sponsors of the series, once again, the University of Toledo College of Engineering and AAA of Northwest Ohio. Now watch for notification of our 9th Technology Takes the Wheel seminar during Engineers Week, which will be February 26th, 2021. Hard to believe, that is right around the corner. The topic will be pedestrian and bike safety. Now, the link to the recording of today's event will be sent to all attendees next week. And if you registered for CPD certificates, those will be emailed next week to the address you provided. Thank you so much for joining us, and what a great day it was. Proud to be part of it. Have a wonderful afternoon, everyone.